which is going to be for our feed pet. So that was a void returning function. Let's specify the name of the class, colon, colon, and then we can select it from our list here. So Eclipse is nice in helping us out and providing a list of member functions. And what we have to pass in is the amount of food that we're going to feed the pet. And the first thing that we'll do is just look at the condition of how much we're actually feeding our pet, whether it's going to be hungry or not. So we'll say if, this is just according to our problem statement, if the amount is greater than or equal to 0.5 times the weight, then what do we know? We know that in that case, the hungry status will be false. So we'll set hungry to being false. Otherwise, else, the hungry status will be true. So this particular function here is actually modifying one of our data members, right? So our data members were for weight and hungry, and we just modified the hungry. And it also modifies the weight variable as well. So we know from our problem statement that the weight will just simply be the current weight plus 0.5 times the amount. And this is just some arbitrary thing that we came up with here for this particular problem statement, but that's how the weight is actually going to change. All right, so that is all we need to do in that particular function. Now, some of you may be asking whether we should change the weight after this condition. And yeah, we should do that. And the reason why is because we're doing a comparison between amount and weight, and we want to do that comparison before we've actually modified the weight here. Okay, let's write our next function. So our next function is just a basic get function. So that was our next two, get hungry and get weight. So the first one here for get weight is an int returning function. So int vpet colon colon, and this is for getting the weight. And this is a really simple function. It just simply returns the weight. Okay, so how easy is that? And then we're going to do another function similar to that, except this is a Boolean returning function, vpet, and this is for getting whether it's hungry or not. And we will return hungry. So with these two functions here, we're able to actually get or read what the current weight is and what the status is, whether the pet is hungry or not. If we did not have these functions here, we would have no mechanism to get to these data members here, because guess what? They are private, so we'd have no mechanism to get to the weight or whether it's hungry or not, other than performing these get weight and get hungry functions here, or calling these particular functions here. All right, so I think we're pretty much done, at least for now, in defining our class. So we defined the header file, which basically gave us our interface. Here's where we declared our class called vpet. We defined the public and the private parts. We defined two constructors, one of them being the default constructor if the user didn't specify anything to us. We also defined our member functions that allowed us to feed the pet, and also get what the weight is, get whether they're hungry. The implementation or the actual definitions are over here in vpet.cpp. So we've done a good bit of work here in terms of just laying out the basic structure of defining a class, and also understanding this concept that when we're defining a class, we're looking at defining the data and operations of things. So let's go ahead and save this, and I know we'll get at least one compile time error message, but let's see if we get any more. So I'll go ahead and save everything, and then click on the build button and see what happens. So yeah, we did get one error message here, and that is that we do not have a main. So we cannot really build an application in C++ unless we have a main function. So what we'll do is actually create a third file that will have our main function. Okay, so let's go and create a file that actually has a main function. So over here on Program 7's project folder, right click, go to new, and then select source file. And the name of our source file is just going to be the same as the source folder. So we'll just call it program7.cpp. And click on Finish. And now we have our new source file here. And the first thing we'll do is pull in a couple of libraries. One library we need to pull in, or at least the header file for the library, is the IO stream, since we're going to be making use of cout. The other thing that we need to pull in is our header file for vpet, since we're going to be making use of that class. So let's go ahead and do a #include, and we'll do vpet.h. And we'll also do our using namespace standard. And then we'll come down a couple of lines, and now we'll define our main function. So int main open paren, open brace, close brace. So without this main function, we do not have a C++ application. We have to have a main function. But the cool thing is we've actually written this class over here for vpet, and now we're going to make use of it over here in program7.cpp. Okay, so the first thing that we're going to do is just simply create a brand new virtual pet. So we got to specify that we want to create a virtual pet. So this is basically the type, and we're going to just give a variable name here called Bob. So our virtual pets, whenever we defined it, they don't actually have a name as one of the attributes or one of the properties. So our data members is just simply the weight and whether they were hungry or not. So we had a Boolean value there. Later on, we can make improvements to this particular class and actually associate a string variable for the name. So maybe that will become a third data member. But for right now, we'll just assume that their name is associated with the variable name. Okay, so what we're going to do is actually invoke the constructor that we wrote. The very first constructor, which was not our default constructor, it actually expected 2 arguments to be supplied, one for the weight and one for whether they were hungry or not. So I'm going to just put in here open paren and say that the weight was maybe a 150 and that that it was not hungry. So we'll put false here so we could have a true or false value there. So this is actually creating a brand new virtual pet for us through the invocation of that constructor and initializing it with the appropriate values. And the other thing that we'll do is actually feed Bob. So let's go ahead and feed Bob, and we'll say that we feed Bob. Well, I guess I need to invoke the function. So Bob dot, and then we'll specify the function, which would be feed pet, and maybe we only feed him 25, whatever the units may be. So these units could be kilograms, ounces. It really doesn't matter. This is just some unit of weight. So we've created Bob here, and we've also fed Bob. Let's create one more virtual pet. And this time, the virtual pet that we're going to create, we're going to just use the default constructor. And the way we do that is we just specify the type, and then we are going to specify the name. And maybe the name of this virtual pet is Sam. So you may be tempted to do an open paren, close paren here, but you should not do that. That is not going to actually invoke the default constructor. We just need to have vpet and then some name here, and this would actually invoke the default constructor. So no open paren, close paren there. And we'll also feed Sam. So we'll say Sam dot, and then we'll select our function, or you can type it out, and we'll say that we feed Sam 10 units. Okay, so we have that. So let's go ahead and do a couple of cout operations, and we'll say cout, and then say Bob weighs, and maybe a colon here, space, and then we'll use our little insertion operator again, and then we'll say Bob dot, and then we can just simply call on this function here called getWeight to find out how much Bob actually weighs. Because remember, we do not have direct access to Bob's weight. So we couldn't just simply do Bob dot, let me go back here and show you. We couldn't do Bob dot weight here. And the reason why we cannot do this whenever we would go and try to actually run this particular program, this is actually private information. We cannot get access to that. Actually, let me go ahead and show that to you. Let me go ahead and add a return 0 down here and a semicolon. Go ahead and save all this and build it. Okay, so we get an error message down here. It says weight is private, so we cannot do that there. That's why we had our little function there called getWeight. So getWeight allows us to get to that private data member. But the cool thing is we can only do a read of the weight. We cannot actually change the weight. So if we had unrestricted access, if we had that weight as being public, we could actually modify the weight. But that's not how we want to have the clients of this class working on the weight. We only want the weight changing whenever we feed the pet, at least for right now. If we add in walking or exercising later on, maybe Bob can lose weight, so we'll be manipulating the variable that way. So let's do another cout operation, and we'll say Sam weighs, and we'll use our insertion operator, Sam dot get weight. Okay. So these get weight functions are dependent upon which particular virtual pet we're talking about. So if we're talking about Bob, we're getting Bob's weight here. If we're talking about Sam, we're getting Sam's weight. So that's an interesting concept. We cannot just simply specify get weight. That will not work. So let me save that and just show you what happens if we try to specify things like that. So I'll compile this, and it gives us an error message. It says get weight was not declared in the scope. So what it's expecting is this is a function that maybe we should have declared inside of this particular program here. But it doesn't recognize get weight. We'd have to specify what particular virtual pet we're talking about. So we're talking about Bob. So bob.getWeight. Okay. I'll save that and compile again just to show that we do not get any error messages there. All right, so now that we have this, let's just go ahead and we've already compiled it. So we did a build here, so that compiled it. We didn't get any error messages. Let me go ahead and run this program and see what we get. So we get Bob weighs 156 and Sam weighs 102. Notice that we didn't get any sort of fractional part here, and you probably would expect that we would have gotten a fractional part whenever we did these operations, because whenever we did our multiplication, right, we were doing a multiplication of the weight by 0.25, so 0.25 times 10 would be 2.5, and we didn't actually get a 0.5 onto the weight here. That just got lopped off, and the reason why is we have the weight defined as an int value. So the weight here was defined as an int. Get weight is returning an int value. Let's actually go in and change these to doubles, since that would make more sense in terms of not losing that fractional part and it just being lopped off. So we'll go in here and change all of our ints to doubles. So there's three places that we had to change int to doubles. 2 times here inside of vpet. So we had to change this guy to a double. We had to change the weight to a double here. And then we also had to change the return type here for the get weight definition inside of vpet.cpp. So make sure you make those changes. So go ahead and save all those. We'll build once again. And let's run our program. So yeah, this time we actually get the fractional part. We get to 156.25 and 102.5. So let's go back over here to program 7 and maybe add in one more thing. Let's test out our getHungry function. So our getHungry function returns a true-false value. So we can do something like this. Maybe we can ask the question and see if Bob.getHungry. So we'll do a getHungry there. So we know that returns a true-false value. So if this turns out to be true, we'll just do a cout operation and come in here and say Bob is hungry. And we'll do an endl here. Else, what do? We'll say cout Bob is not hungry. Okay, so let's go ahead and save that, build it, and we'll see what happens. All right, so we got the same information as before, and we also got the statement here that Bob was hungry. Now notice that when we first created Bob, he wasn't hungry. We specified the hungry attribute as being false. But whenever we fed Bob, notice that whenever we fed Bob here, we fed him 25. And what was our condition there for him not to be hungry? Well, the amount of food that we fed him had to be greater than or equal to half the weight. So Bob weighed 150 pounds, right? So whenever we fed him 25, that was not half of Bob's weight. So half of 150 would be 75. So 75 is greater than 25, or 25 is less than 75 is maybe the way we should think about it. So it did not meet this criteria for him not to be hungry. So I guess, we kind of whet Bob's appetite there and made him hungry by feeding him, and it wasn't quite enough food to satiate Bob. So that is not a good thing, I guess, for Bob, but that's okay. We got a virtual pet going on here, and maybe we can feed him some more later on. The thing about it is now Bob weighs more, and we'll have to feed him more. He's kind of a blob, Bob the Blob. Okay, so I think that's pretty much most of what I wanted to talk about for this particular program for now. We want to make some improvements on it in the future. The other thing is, if we tried, some of you may be thinking, oh, well, why not just do cout and then specify Bob and then do endl? So maybe you think that if we can just do this, we can print out Bob's weight and also whether he's hungry or not. But if we try to compile this code, you'll notice that we get a lot of stuff going on here. And if we scroll back up to the very top here, near the top, here on the console window, we notice that we don't have a match here for this insertion operator. So the insertion operator knows how to work on our types like strings, ints, doubles, everything that we've used so far, but we've defined a new type here called vpet, virtual pet, and it has no idea how to handle that. So Bob is of type virtual pet, and it doesn't know how to perform that particular insertion operation for that. But what we can do is actually perform what's called operator overloading, and we'll probably look at that in an upcoming video where we can actually go in and define the behavior that we'd like to have when we perform this insertion operation. So let's go ahead and just remove this line of code right now since we don't have an actual overloading of the insertion operator. Save everything, build it just so we have a complete clean compile and linkage, and we'll run it one more time. All right, so that's pretty much it for this particular video. In the next video, we'll talk maybe a little bit more about this program, and certainly coming up soon, we'll look at operator overloading.